and then I'll start the recording, and then we'll get started right at 11 my time in about 2 minutes.
Okay.
The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, this is Mark Swafford of the DBAFundamentals virtual chapter. We'll get started the meeting here in probably about a minute and a half. All right, it's about that time. I'd like to welcome everybody to the DBA Fundamentals virtual chapter meeting for September. Today's presentation is entitled Going Asynchronous with Service Broker. It'll be presented by Jonathan Cahias. I'll be turning everything over to Jonathan here in just a few minutes, but have to take care of a little bit of house cleaning. First of all, my name's Mark Swafford. I'll be moderating the meeting today. I'm the president of the DBA Fundamentals virtual chapter. My co-moderator, Stephen Cantrell, will also be helping out. You can contact us at fundamentals.sqlpass.org, our website through Pass for the DBA Fundamentals virtual chapter. If you look on the About Us tab, all of our contact information is there, and you can contact any of the 3 chapter leaders, and we'd be happy to answer your questions. I would like to let everyone know on September 8th, in about a week, we will have Robert L. Davis, who will present a session called SQL Server Performance Tuning. It's controlling parallelism, and interestingly enough, it will be our first meeting, DBA Fundamentals meeting, in the Australian Eastern time zone. So for those in the United States, that'll be 10:30 p.m. Eastern time on September 8th, which is kind of cool. On 10/6, we will have Tim Radney will present a session that's called Common SQL Server Mistakes and How to Avoid Them. So that'll be great. You need to catch that. So as you can see, we have a ton of things going on. Just want to let you know that this session is being recorded, and it'll be available in our archive section on our website within a week. It's usually only a day or 2, but we'd like to say within a week. So for those of you that have to, check out earlier, you want to watch it again at a later date, you're welcome to do that. So I also want to mention we have a couple of giveaways. So first of all, I'd like to say congratulations to Tracy Morant. She is our $200 gift card winner. What we did is we randomly selected a winner from all of those users that used our comp code to buy their tickets for the Pass Summit here in a couple months. And Tracy, congratulations, she is the winner. Now, for those of you that are logged in today, I also want to say that we will be taking the attendees in today's session. We'll send those names to Pass, and Pass will select a winner from today's session to receive a free ticket to the Pass conference, the Pass Summit later in the year. So that's kind of cool as well. So let's talk about today's topic in today's meeting. We have, again, Jonathan Cahias, and he is with SQL Skills, and he's presenting Going Asynchronous with Service Broker. So Jonathan is a principal consultant with SQL Skills. He's the youngest person ever to achieve the Microsoft Certified Master SQL Server certification and has been a SQL Server MVP for a number of years. So Jonathan's heavily involved in the SQL community, including being the top answer on the MSDN database engine forum, which is really cool, writing deep technical content on his blog, plus his old blog, and answering questions as, is it SQL Pool Boy on Twitter? Without further ado, I'd like to turn it over to Jonathan, and we appreciate you being here today.
Sure. So this is a session I actually did at Past Summit last year, slightly modified on basically getting started with Service Broker. When I talk to people about Service Broker, there's a big knowledge gap there. So hopefully this session will let you see just how easy it is to get Service Broker up and running to process things asynchronously inside of SQL Server. So as Steve said, I am a member of the SQL Skills team. I work with Paul Randall. It sounds like it's a great thing, but it depends on the day because I get fired a lot. But we do a lot of instructor-led training called Immersion Events. We also do training online on Pluralsight. I'm actually in the process of recording 3 different classes on Service Broker that will be available on Pluralsight in the next month or so. This is information about our immersion events that we do around the world. We were in Sydney, Australia earlier this year. Paul and Kimberly just got back from London. So we offer a lot of deep technical training that covers multiple weeks of topics. And then on Pluralsight, we're recording a lot of our content. And if you email Paul at sqlskills.com, with the subject line, it should say DBAFundamentals Pluralsight code. He'll send you a free, there's no catch, no credit card required, 30-day trial that will give you access to our SQL Server content on Pluralsight. So about me, I call this my Yay Me slide. I won't spend a lot of time here. The most important thing is my email address, jonathan at sqlskills.com. If you have a question about the content that I covered today or issue with using the demos that I'm going to provide for Service Broker, feel free to shoot me an email and I'll try and help you out. So what we're going to talk about in this session is just a quick overview of some Service Broker usage scenarios, some of the advantages of leveraging Service Broker, and then we're going to do a basic Service Broker architecture for a single database solution and go over how conversations happen between services and how you can automate things using activation at the end of the session. So these are probably my 2 favorite usage scenarios for Service Broker, and I've implemented them for different customers at different points in time. Asynchronous trigger execution. If you have really complex logic that exists in either DML triggers that will affect your OLTP performance, you can offload the execution of that logic into Service Broker and let it run asynchronously a lot of times. So you basically implement a queue of a message that's going to request work to be done, and then Service Broker is actually going to process that logic in a separate transaction asynchronously. The other way that I've leveraged Service Broker is reliable processing of queries, and this doesn't always seem like something that you might need. But at one time I had a customer that they maintain a large amount of data and they get a lot of requests for that data. And one of the challenges that they had was if something happened to the service, they wouldn't actually fulfill all the data requests, and it was a requirement that they had. So instead of actually running requests in real time, what they do is they queue a message that includes the data that is being requested, and then asynchronously those messages get processed in the order that they're received, and the actual data being pulled from SQL Server is sent off to whoever the requester was, either by email or it becomes available for download through their website. And the really cool thing about that is it guarantees that every request for data is going to get serviced at some point, even if there's a service failure. Because the transaction that is processing that query, if the service fails, is going to return the message back to service broker and require it to be restarted for processing whenever crash recovery occurs. So it's a really great way of making sure that if you have things that have to be processed and have to succeed, it allows you to make sure that you get that reliable processing of the queries being executed. Some other usage scenarios, I've worked with a couple of centralized data collections where you have multiple sites processing transactions, and then service broker sends that information to a central database. And the really cool thing there is that the asynchronous nature of service broker allows for any kind of local sales transaction or other operation to continue even if the site loses connectivity to the central office. It'll just simply queue those messages locally until the connectivity is restored, and then it will drain the transmission queue from service broker out to the other service that should have received those messages when it comes back online. And another usage scenario would be if you wanted to do distributed server-side processing. And in the United States, we have a service called Fandango, which is an online ticketing company for movie theaters. And if you think about an online ticketing application that processes orders, it's going to exchange data between payment processing, a customer relationship management system potentially, and then even the ticket printing applications are kiosks at a movie theater where they're actually going to print the tickets after validating that payment's been received and everything's good with an order. Some of the advantages of leveraging service broker, the biggest one is database integration. It removes the overhead of having a separate distributed transaction coordinator to keep a transaction enlisted across multiple systems. And the message store is maintained as a part of the database. So it's at the exact same transactional point in time. And if you do a backup restore, your service broker configuration and messages are going to be included in that backup restore. So you don't have to do any kind of reconciliation between the database and the message store when one of them has to be restored, like you would with something like a MSNQ or an external queue-based messaging implementation. Within Service Broker, the messages are received once and only once, and they're processed in the order that the messages are sent based on their what's known as a conversation group or conversation handle. And all of the related messages to a single conversation handler group are going to be locked simultaneously to prevent out-of-order processing from multiple transactions, but multiple threads can process different conversation groups concurrently. So this is a way that you can kind of increase scalability and get better performance out of Service Broker if you're working with automated activation and allow multiple queue readers to actually execute inside of the process. Service Broker does allow loose coupling of your applications. The asynchronous nature of Service Broker is really the thing that I try and leverage the most and that I like the most. Anything that might run for a long period of time that I need to guarantee is going to succeed, I like to decouple that from the application, because if somebody has a thick client for an application, they could have a network hiccup, and if it's a long-running transaction, it's going to have to roll back. It's not going to complete. They're going to have to start over again. But if we decouple that from the actual application tier and we submit it to Service Broker for processing, it's going to run on the server. It can run parallel, and it will process in the background, and should there be a failure with SQL Server, it's always going to restart that operation after crash recovery occurs. And then the other advantage is if you configure it, and we'll talk about this at the end of the session, automated activation allows it to automatically scale performance to match the volume of messages that arrive in a given service queue. It allows you to write applications to process messages inside of the database using Transact SQL. It's a simple store procedure. Or if you have really complex processing that needs to happen, you can write an external activator application and leverage either the external activator feature that was shipped with SQL Server 2008 for Service Broker, or you can write your own external activation into your application as well. But basically, anytime a message arrives on a queue within Service Broker, it will start a new queue reader when there's work to be done, and then they automatically will time out and expire inside of the system. So there's a question, can I replace Service Broker with my ETL process to transfer data between my SQL servers? Should I have an enterprise license? I've used Service Broker for automation of ETL processing, and even as a part of building an operational data store with real-time data movement between applications and systems. It's not a direct replacement for ETL operations in a lot of cases, and you're going to have to do something, typically you still have to do something with SSIS or another ETL tool that is designed for doing ETL. But there are implementations that use Service Broker for moving data and pushing data to staging tables as it changes in the production system to kind of offload that and keep it near to real time. Service Broker doesn't require Enterprise Edition. It's actually a part of Express Edition, and you can have integrations between Express Edition, Standard Edition, Web Edition, Enterprise Edition by simply configuring all the Service Broker networking components, which we're not going to talk about today. Would you use Service Broker to replace replication? That's an interesting question because I was just having this discussion with a client about the benefits of leveraging Service Broker versus leveraging replication or CDC for ETL operations. And I wouldn't replace replication with a customized Service Broker implementation because there's a lot of things that replication does that it'd be difficult to duplicate that with Service Broker. So it kind of, I hate to say it this early in the session, but it depends. Kind of our answer to certain questions, because it depends on what you're trying to do. Service Broker might be a better fit for certain things than replication. Replication might be a better fit for other things. So it really depends on what you're trying to accomplish there. So one of the things a lot of people might not realize is that Service Broker is leveraged internally by SQL Server for a lot of features. Event notifications piggyback on Service Broker. It's kind of where I got my first experience working with Service Broker, because when you configure an event notification, you have to configure a Service Broker queue and service that listens for the events. Query notifications inside of SQL Server that monitor changes in data results are leveraged for external queue activation with Service Broker. And the database mail feature is actually implemented as an externally activated application that monitors for messages being queued in MSDB to actually do the send mail part of sending a database mail message. And then WMI events, if you've ever configured a SQL Agent WMI alert, they piggyback on event notifications and allow integration with the Windows Management Instrumentation framework inside of Windows as well. Is there a need to set up MSDTC in a clustered environment? That's not for Service Broker. You don't need MSDTC for Service Broker. Whether you want to have that configured in a clustered environment is a huge discussion on its own. It's not required, but it depends on what your requirements are. Can I write an MDS workflow and capture Service Broker messages and manipulate MDS data? I'm guessing you're talking about master data services, and I don't know anything about the MDS workflows. All that you would do to see the Service Broker messages would be process the messages from the queue, and however you would do that within the MDS workflow, it could anything basically that can query the queue or receive messages from the queue can be a consumer of the Service Broker data inside of SQL Server. So the basic Service Broker architecture, I've done this a number of times just as a single database implementation. You don't have to have multiple databases involved to work with Service Broker, and a lot of times for the asynchronous processing, a single database implementation is all that is actually necessary for things like asynchronous trigger execution or doing the reliable processing of queries. You enable the database for Service Broker, create a request or reply message type if necessary, create a contract that specifies your request messages are going to be sent by the initiator, and reply messages are going to be sent by a target. Create your target, initiator, queue, and services. And when you create the target service, specify the contract as a part of the service configuration. And what that does is limits the conversations that can go back and forth to that service. And excuse me, when you create the initiator service, it doesn't require a contract. It can be configured just as a service. And what that does, if you don't specify a contract, is it doesn't allow it to be a target of another broker implementation or broker conversation. So the 4 types of objects that you're going to need to configure for the basic service broker architecture is message types that define the messages that are going to be sent, a contract that's going to specify the initiator will send one type of message, the target will send another type, a queue for each of your services, and then your 2 services defined. So the message types inside of Service Broker are basically the name and type of data that will be contained in a message that we're going to send between our services. And SQL Server can do validation of the message to contain valid XML. You can make it conform to a XML schema, or you can have it validate that the message contains no data at all. The other thing that you can do is not do message validation, and this allows you to accept any type of data, including binary data or empty messages, as a part of sending a message. And then there are going to be system message types that exist inside of Service Broker for handling errors and dialog status. And there's a default message type that gets used anytime you don't specify what the message type is for a message being sent. The contracts define which message types are going to be used for different tasks. When we talk about Service Broker tasks, they're typically in either the initiator or the sender and the target or receiver of a message. And it's basically the agreement between the services about what type of message is going to be sent to the other service for a given task. Can Service Broker and PowerShell play together? You could query Service Broker through PowerShell. You just write queries the same way that you would, or execute a stored procedure that would process the messages the way that you would from T-SQL. It's all direct transact SQL access, though. It's not. There's not an API that PowerShell that I know of natively hooks into Service Broker. So our queues in Service Broker are basically our message store. They're backed up, or they're backed inside the database by an internal table. And when messages arrive at a service, the service inserts the message into the queue that is associated with the service. Every row in the queue is going to contain the contents of the message that was sent, the message type, and what kind of validation was performed. The name of the service and contract that was targeted by the message, the conversation the message is associated with, and some additional internal information that is associated with the queue. Your applications are going to have to use the receive command to receive messages from the queue. And you typically receive messages within a transaction that can be rolled back to guarantee that you can see that message again should something fail or the service have a problem. You can also use a stored procedure for internal activation, which is going to automate processing, and we'll talk about that at the end of the session today. And I'll show you a demonstration of how you would do that. And then our services in Service Broker basically specify the name of a business-specific operation or task that's going to be implemented inside of Service Broker. And a lot of the demonstrations or examples that you see online use web addresses or URLs for service names, and they don't require that. They can be anything from just my simple service to a complex URL that defines your business process. If the naming convention for Service Broker objects is entirely up to you. You can name it the same way that you would anything else inside of SQL Server. But the service names get used as a part of the routing and delivery system inside of Service Broker to deliver the messages to the correct queue inside of the database and to route messages from the target to the initiator and back. It also determines your security requirements for any new conversations and can enforce the appropriate contract for the conversation so that you don't send incorrect message types that would break something inside of Service Broker. And every service is bound to a specific queue to store the incoming messages for processing in Service Broker. Now, in Service Broker, sending and receiving messages is what's known as a dialogue conversation. So it's basically a persisted stream of messages that go back and forth between two services. And dialogues provide what's known as exactly once in order message delivery. Using a conversation identifier, which is a unique identifier for the conversation handle, and sequence numbers. And there's going to be two participants. We've already kind of touched on this: an initiator, which is going to start the conversation, and then a target, which accepts a conversation started by an initiator and receives messages that will be processed. The target can also respond back to the initiator with its own message that can be processed on the initiator side, but that's not necessarily a requirement. We'll talk about why you would want to do that in a couple of slides. But the initiator starts the conversation, sends a message, and the target service accepts that message and queues it, and at some point you'll process that message from the queue and either in the conversation, which is called fire and forget. I'm not a big fan of that because it can create issues. A lot of times it works without creating issues until something changes, and then as a part of doing fire and forget, messages never get sent back to the initiator saying that work was complete. So conversation handles might be leaked, or other problems can pop up. And I'll reference a blog post by Remus Rusanu that talks about fire and forget and why you should have a back and forth exchange of messages occurring inside of Service Broker. So to process messages, you're going to use the receive DML statement. You can query messages off of the queue by doing select star from the queue name, but when you do that, all you're doing is kind of taking a peek at the queue and looking at what's maintained on the queue stack. You're not actually processing the messages from the queue. To process the message, you have to use the receive command. And there's three different ways that you can do this in Service Broker. You can receive a single message using top one. This works for very small amounts of messages. It's kind of easy to implement, but it's a slower method of doing processing because it's row by row, message by message processing. You can receive all the messages for a single conversation into a table variable, and this can be faster because you can grab a big chunk of messages into a table variable, and if you're using XML to send data around, you can shred that in a single operation, and it becomes a little more efficient for processing. Or if you're using conversation groups, where you can basically group different conversations between different services together and under a master conversation handle, you can receive everything associated with that conversation group into a table variable, and that's also a faster method of being able to process messages off the queue. The messages are always received in sequence order per conversation or conversation group from the queue. So it's, again, that exactly once in order processing that is ensured by Service Broker when we're processing messages. And then anytime we issue the receive command or statement, it's going to lock the conversation using an internal lock in SQL Server that is specific just for Service Broker, so that nobody else can access that conversation handle while we're receiving it, receiving messages associated with it from our queue. This can become a bottleneck if a single conversation gets used for all messages, and it's kind of a scaling trick that the SQL Cat team wrote an article about called the 150 rule, and you create a separate conversation, you create 150 conversations and only maintain one of the conversation handles because of an internal latch. And basically, for the page that maintains the conversation handles in SQL Server, it takes 150 separate conversations to fill the page. And it's kind of a throwback to the old trick of if you have internal latch contention on a hot page, one of the things you could do is put filler data, like a inchar 2000 column that defaults to an empty field. And what that basically does is it forces one record per page, so that when you have a hot page, it no longer has latch contention against other processes trying to access the same page, because everyone ends up on their own page. So there are a couple of tricks for getting better scalability, better performance that exist. That Cat Team white paper is a really good read if you're looking at doing a lot of service broker activity and you see that you're having in-memory latch contention. That's one of the tricks that's there for being able to reduce that contention. And the other thing that you can do is reuse the conversation and use a dialogue timer that causes it to time out at a certain point so that you can clean it up and then create a new conversation. So there are a number of ways that you can scale this really well using different implementations. Anytime that you're processing a message, you want to do it inside of a transaction so that there's error handling that can occur, and you can roll back the transaction if there's a problem. But you want to make sure that you are careful about how many times you roll back a transaction associated with a service broker message, because you can end up with what's considered to be a poison message. And basically, when you roll back a transaction, that message goes back on the queue. Because there's work to be done in the queue, and you have automatic internal activation configured with a stored procedure. The next time that stored procedure starts and executes, it's going to receive the same message. Since it failed to process that message once, it's going to fail to process it again, return it to the queue. When the queue sees a message 5 times in a row that has been rolled back, it will actually disable the queue from processing because of poison message detection. Otherwise, you'd end up in an infinite loop processing a message that can't be handled by the system. So that's one of the things you want to monitor as a part of implementing Service Broker is the disabled queue event notification to know that the queue is getting disabled for some reason, and maybe just have that event notification fire an email off that says, this queue was disabled inside of Service Broker, it needs to be looked at. And there's different ways that you would go about troubleshooting that. A lot of times I'll disable any automated activation so that I can bring the queue back into an enabled state, because if you enable a queue and you leave automated activation on, it's just going to go disabled again as soon as activation fires, and it rolls back 5 times for that same message. So if you remove the automated activation, the next thing I like to do is execute the stored procedure that would have been used for activation. And I like to do that because it's going to output the error associated with the message. And I can do a little more diagnostic work from that. And it may be that I need to fix something with the message, I need to fix something with the stored procedure. There's a lot of different reasons that you could have poison message detection that would trigger or occur and create problems in Service Broker, and you just kind of have to work through each of those scenarios based on what's output when you run that stored procedure manually. Now, dialogue conversations in Service Broker all have a unique conversation handle associated with the conversation. You create that conversation handle using begin dialogue conversation on the initiator side using T-SQL. The conversation handle gets retrieved from your target queue when it gets processed, and I'll show how you do that using the receive command. It's one of the columns that you're going to have to pull back with the message because you need that conversation handle to either end the conversation from the target to the initiator, or to send a message back to the initiator acknowledging receipt of the message. Some of the interactions between Service Broker require a back and forth series of messages on the same conversation. And I typically, anytime I'm configuring anything in Service Broker, I make it do a back and forth series of messages, even if it wasn't entirely necessary, so that the initiator is the side that ends the conversation when it processes what would be the final message from the target. And then the target will receive a in dialogue message from the initiator side, and it will then execute its own end conversation on that conversation handle to clean up and avoid orphaning that conversation. And this is where the Fire and Forget blog post from Remus Rousseau, he makes the statement, it's good for the military but not for service broker. And basically Fire and Forget's where you send a message, you begin a conversation from the initiator to the target, you send a message, and the target processes the message and then just ends the conversation without sending anything back over the wire. And that can create problems in a number of scenarios where, especially where you're doing dialogue reuse and you're using the same conversation handle on the initiator side. If the target ends the conversation and the initiator doesn't handle the end dialogue message or process it correctly, what the initiator can do with conversation reuse is attempt to send a message that is going to go on a conversation handle that's already been closed, and it's not it ends up being an error inside of Service Broker. So having the initiator be the one that initiates the end dialogue or end conversation execution allows it to be the side that has control over when the conversation is actually going to be closed out. So a basic example of sending a request message. You'll begin a conversation at the initiator and specify begin dialogue. And when you do that, you have to specify the initiator or sending service name, the receiving or target service name, and the contract that is going to govern the conversation. So once you have that, you're going to get returned a conversation handle associated with the new dialogue that you're conversing with, and then you send a message using send on conversation and specify the message type that's going to be sent and the message body that's going to be sent. Once the message is sent through Service Broker, it will get to the target service. The target service will queue the message into its queue, and then you can process that message by receiving the message from the target queue with the receive command, and then send any response message from the target to the initiator after you do whatever processing needs to be done using send on conversation, and you specify the message type that's going to be sent back and the message body that's going to be sent back. Once that has occurred, if you're sending messages from the target back to the initiator, you're going to have to go to the initiator side, receive that response message, handle it appropriately, and then the last thing you would do is end the conversation at the initiator using end conversation, specifying the conversation handle. And when you do that, it sends an internal message, a system message called an end dialogue message to the target service, and the target service implementation or application that processes the queue needs to check and verify the type of message that it's processing, and if it's an end dialogue message that's coming from the initiator, it needs to execute its own end conversation command on that same dialogue handle so that it cleans up the conversation on its side. So let's flip over to my virtual machine and take a look at how we do just this very basic architecture and setup of Service Broker in a single database. So the first thing I'm going to do is create a new database called Single DB Broker. And once I've created the database, we're going to enable Service Broker for that database. And then we're going to change to the database and create two different message types. So in this case, I use a long name, the database name, and then the name of the message that's going to be referenced. In this case, request message and reply message. They're both going to be validated as having well-formed XML. So I'm going to pass the information back and forth between my services in a XML document. And once we create our messages, we can take a look at the messages that exist in Service Broker by querying service message types. And in this case, I'm filtering where message type ID is greater than 65535 because everything below that is a system message. So if we wanted to look at our system message types, you'll see there's a error message type for when errors occur inside of Service Broker. There's the end dialogue message, which is sent anytime that a end conversation occurs between the services. There's the query notification and event notification message types associated with those two features inside of SQL Server. The dialogue timer message type is there to allow Service Broker to fire an event and expire a conversation if you set it up with a dialog timer. And then there's other configuration related ones within Service Broker for missing routes, missing service bindings, failed service bindings, and then the default message type exists as well. So now that we've created our message types, we're going to define a contract, and this we're just going to name it sample contract, and we're going to specify that our request message will be sent by the initiator, and our reply message will be sent by the target. And if we look at our newly created contract, we can see the name of it, its contract ID, and we can also look at our system contracts that exist as well. There's the post-query notification one associated with query notifications in the engine, and there's the post-event notification for event notifications as a system contract as well. And then the broker configuration, notice, service echo, service diagnostic contracts are internal to Service Broker. So once we've created our contract, we need to create our target queue. So if we look at our service queues, where it's not a Microsoft ship queue, we can see our target queue in the system. If we look at where it was shipped by Microsoft, you'll notice every database will have a Service Broker queue, an event notification errors queue, and query notification errors queue associated with it. And those are just internal queues for Service Broker shipped by Microsoft. So once we create our target queue, we're going to define the target service on that queue. And the target service is going to bind the sample contract to our target queue. And you have to specify that contract as a part of this service for the target service. Otherwise, a message couldn't actually be sent to the service. So this is going to, when you attempt to send a message to the service, it's going to validate that the initiator is sending its request message, and it governs the fact that the target can respond or reply with a reply message. So we'll create that. And again, if we look at our service information, this is our user-defined service, and then there are additional services for event notifications, Service Broker, and query notifications. So our target side's configured. Now we need to create our initiator. So we're going to create the initiation queue, and we're going to create our initiator service, but we're not going to specify a contract here. And the reason we're not going to specify a contract here is I don't want something to be able to send create a new conversation with my initiator service. It's what starts the conversation. We define the contract on the target service so that we can converse with that service. And by not defining a contract here, it means that nothing can send a message or initiate a new conversation with our initiator service. However, since the target service was already enlisted in a conversation by the initiator service, it can respond and send messages to the initiator service based on its contract definition. So if we check our services again, we'll see we have our target service and our initiator service. So very easy to get a basic configuration, and that's the basic components of Service Broker put together. So if we wanted to send a request, and I'm going to open all of these at the same time. We'll use our database, and then to begin our conversation, we're going to do begin dialog, specifying from service, being our initiator service, to our target service, and we're going to use our sample contract. And we need to declare a unique identifier variable, in this case, the dialog handle for our initiator. And what we're going to do is we're going to specify that so that we have access to the conversation handle associated with the dialog that we're beginning. And then we're going to create a request message that just says message for target service in XML. And we're going to send on the conversation handle that we just created a request message type and the body of that message from our variable. The last thing we'll do is select our message body that we sent and then commit our transaction. So if we do this, we have our request message that we sent, and then if we look at our conversation groups DMV, you'll see now that we have a single conversation group ID associated with that. And if we just query, we take a peek at what is in the target queue and cast the message body as XML. So let's run these two together. Did we send that? Let's do this again. Something didn't work out right there. Well, that's not good. So this isn't a part of the demo, but something in the last 40 minutes has not worked out right in this demo. So we're going to take a look at our sys transmission queue in the database. And this is basically the queuing point for messages inside of Service Broker when there is an issue. Oh, beautiful. So what this is complaining about is my domain controller is not up and running, so it can't validate against Active Directory. So what I'm going to do is go back over here and let's change our connection. And rebuild this as the SA user in this environment. So I'm going to remove the database. I'll create it again. We're going to set up all the Service Broker items. And if we come back over here now, use our Service Broker database and send a message. Look at our conversation group. Look at our target queue. And here you can see the request message. And if we query these together, what I was trying to show is that the conversation group ID is going to match what was created here inside of our Service Broker target queue for processing that message. So to process the request, we'll use our database, and we're going to create 3 different variables that we're going to use. And yes, all of the scripts and demos will be available for download. They're on our resources page already, but I will make sure that they're provided to the group for being able to download it as well. So we're going to get our request dialog handle as a unique identifier. We're going to get our message and then our message type name associated with the message that we're receiving. And what we're going to do is receive the first message off the queue. And when we do a wait for here, we're basically waiting for a timeout of 1 second, and if we don't receive anything off the queue within that second, the code will exit the execution. And this is what allows your automated activation procedures to gracefully exit instead of just constantly waiting. So we're going to receive our message. We're going to select our message that we got. Then we're going to check our message type name. And if it was a request message, we're going to send a reply using the same dialog handle and specify that it's a reply message back to our initiator service. So here we'll run this. So we received the message, we sent a reply back, and if we look at our target queue now, there's no message on the target queue. And if we look at our initiator queue, we should see our reply message there. So now what we need to do is process the message on the initiator side, the reply message we got. So we're going to do the same thing, but we're going to do it from the initiator queue. We're going to receive the message, the dialog handle, and the message type name. We're going to check the message type name. If it's a reply message, we're just going to say, okay, it got the message we sent, it processed it, so now we can close this conversation out. And we're going to execute end conversation on that conversation handle, and then just return our received message or reply message back. So here we can see this is the reply that we got back from the initiator or the target service. And if we look at the target queue, we'll see we have another message here. And this is a message that we're going to have to handle because it's the in dialog system message. And that basically tells the target service that the initiator's in the conversation. We can now clean that conversation up. If we look at our initiator queue, there's nothing in it. So the last thing we need to do as a part of the back and forth interaction within Service Broker is go to our target queue, receive the conversation handle, message body, message type name, check it, and if it's an in dialog message, we need to end the conversation. And this all kind of comes together into a single implementation because we want to check our message type. If it wasn't our request message, we want to have a conditional that says, okay, if it wasn't a request message, is it another message type that we know we need to handle, or is it an in dialog message? Is it a Service Broker error message? And that becomes the full activation procedure that you would implement. So if we look at our target queue, it no longer has any messages. Our initiator queue no longer has any messages. And if we look at our conversation groups, it's empty as well because we've closed that conversation out end to end inside of our dialog. So the dialog conversation is basically the reliable delivery through receipt acknowledgement from the target service back to the initiator service. And there's a number of trace events and extended events for Service Broker that you can watch. It's part of the troubleshooting implementation for Service Broker. When there's problems, one of the things that I do is take a look at what extended events for Service Broker or trace events, depending on the version of SQL Server I'm working with, are firing because if I don't get an acknowledgement back from the target service, that tells me there's something wrong. And the events that fire on the target side or the initiator side can be really, really beneficial for being able to figure out where exactly the problem is inside the system. Any outgoing message that you send, I kind of showed this in the troubleshooting of my domain controller not being running inside of this environment right now, are going to be stored in the transmission queue. And that's kind of my first go-to place anytime that I'm troubleshooting what's going on. They stay in the transmission queue of the sending database until they're acknowledged by the target service. And if they don't get acknowledged, they'll always be in the transmission queue waiting and retrying to send to the target service. If a service is unavailable, the messages stay in the transmission queue. They retry every minute until either the conversation gets ended or the lifetime of that conversation expires inside of Service Broker. And then to wrap things up, the way we automate this is through what's known as activation. And this is typically implemented through a stored procedure, but you can write .NET applications for external activation and processing of the queued messages depending on what your requirements are. When you use a stored procedure, it's referred to as internal activation. The procedure becomes associated with the queue and will start executing automatically anytime a message is popped onto the queue and the queue is enabled. It has to have an owner and it has to use the execute as in its definition for a security context. And anytime that you're doing cross-database access, certificate signing and certificate exchanges are typically the most secure implementation and preferred over turning trustworthy on for the databases and allowing cross-database access to be executed through the trustworthy bit on. You can do external activation outside of the database by writing an application or service. And you can write the activation code right into your own .NET code, or you can leverage the external activation feature, which is installed as a service on the SQL Server or another server. And it basically connects to SQL Server, it monitors the queue for a queue activation event notification, and then it will execute a standard executable or application that that you can do queue processing for as well. So let's look at the implementation of activation. And I know it looks like a lot of scripts. It's really not. It's really broken down just to try and separate things out and isolate things for a little easier flow. So we're going to check if our target activation procedure exists. If it is, we're going to drop it. We're going to recreate it anyway. We're going to grab our conversation handle, message body, message type name, just like we did when we manually did processing of the queues. And we're going to loop infinitely here and begin a new transaction for every time we receive a message. And if the row count is 0, meaning we didn't get a message within our timeout period, which right now is 5 seconds, we're going to roll back the transaction and exit our while loop, which allows the stored procedure to stop executing. We're going to check our message type name. Is it a request message? If it is, we'll send a reply message back on the same conversation handle. If it's not, we're going to check, is it an in dialog message coming from our initiator? And if it is, we're just going to automatically clean up that conversation handle. Is it a service broker error message? If it is, we're going to parse the XML out, raise an error that we received a service broker error and log that to our error log, and then clean up our conversation handle there. So we'll create that stored procedure. And there's a note at the bottom of that. Test your activation stored procedure before you bind it to a queue. That's really important because if there's any kind of mistake or error, you want to catch that as a part of the implementation before just binding it to a queue when you're making changes. So we're going to do the same thing. We're going to begin at Dialog. We're going to send a request message from our initiator to our target service on our sample contract, and then commit our transaction. So the same process we did before. We'll look at our target queue. We have a message there. Nothing on our initiator queue yet. So let's go to our test. So now we're going to simply test our activation stored procedure by executing it. And when we execute it, it should take 5 seconds before it actually returns. And it's already done the processing, but we have to wait for that timeout associated with our wait for to expire. And if we look at our target queue, there's no message there, but we do have our reply message on our initiator queue. So let's go to our initiator queue. We're going to receive that message off the queue, send our in conversation message back so that we get the in dialog message, and then commit our transaction here. And this is making sure that we've tested every part of our activation stored procedure. So if we look at our queues again, now our target queue has a in dialog message, and the next thing we'll want to do is test the stored procedure again. So here we're going to execute the stored procedure. We want to wait 5 seconds for it to return while it waits to time out. And then we're going to query our queues, and we'll see nothing in our target queue, nothing in our initiator queue. Because when we get the end dialog message in our target queue, we just have to clean it up. It doesn't send another one back. So to fully automate this, what we would do is alter our queue. So we're going to alter the target queue. We're going to set activation on. We're going to specify our target queue activation procedure name as our procedure name. And then the max queue readers is the maximum number of concurrent executions of that same stored procedure that could be running based on the amount of messages that or message flow that is coming in. And in this case, it's up to 10 queue readers for the queue. So we're going to enable activation. So let's verify that our activation works. We're going to send a new message on a new conversation. And if we look at our target queue and initiator queue, the target's queue already processed that message and sent a reply back. So that reply is sitting on our initiator queue. So let's handle that reply message and end our conversation. And if we look at our target and initiator queues again, it's already handled the in dialog message as well. So to automate it fully end to end, we're going to basically create another activation procedure that processes the messages on our initiator queue. And we're going to check in this procedure, we'll receive from the initiator queue, check our message type. Is it a reply message? If it is, we're going to end the conversation. Otherwise, did we get an in dialog message? Because we still need to handle those if they come across the conversation. And if it is, we need to clean up our conversation handle here. Did we get an error from service broker? If we did, raise that error and log it. And then we're going to alter our initiator queue and set activation on and specify our activation procedure. So to verify that end to end, we create a new message and conversation from the initiator service to the target service, specify our sample contract, and send our request message across. And if we query our queues, there's nothing in them at this point because the message went to the target service, it queued the message, it executed the target queue activation store procedure, it sent the reply message, it got queued, the initiator queue activation procedure executed, sent the in conversation, which is the in dialog message, and then the target service executed that stored procedure and ended the conversation on its side. And it's very fast. It allows for very rapid back and forth communication. And you can do a lot more. This is just kind of the basic framework, basic conversation architecture for how you would implement the back and forth and have automation inside of the system. So with that, I know there are some questions here that I haven't been able to get to. The scripts will be available. What kind of applications or architectures would need service broker implementations? I like to use it for asynchronous operations, like I said at the beginning of the presentation. Can you use service broker? Can service broker exchange messages with IBM MQ hosted by an outside vendor? It could, but not natively. You would have to basically build some kind of external activation application that would do the communication with IBM MQ. And it basically is going to read messages from service broker and send them there, or accept messages back from it and queue them to a SQL Server implementation. Can you chain a set of messages to create a workflow between a set of services tasks using this? You can. I know a few customers have used service broker, and I got a question at SQL Bits from somebody that was doing it as well, to implement maintenance tasks where they use service broker they queue index rebuild commands, they queue backup commands, and it's all kind of centrally managed by a very large service broker architecture that they put in place to meet their business requirements as a software as a service provider, where customers might request certain things get backed up or processed. You can definitely chain a bunch of messages together in a contract and a back and forth dialogue to implement a workflow between services to meet your business requirements. How can we recover a lost message? You wouldn't lose a message if you received it within a transaction, and if the receive operation fails or the service fails, it should roll that transaction back. It's just like any other modification, and put the message back on the queue. If you send a message and it can't get to its destination, it'll be in the transmission queue, so it's still there. Message reliability is a big part of service broker. You should never have a lost message unless you're not doing things within the scope of transactions in your code, and that would be something I would say that the transaction needs to be implemented and code needs to be changed. How can the processing of messages be sped up? It depends on what you're trying to do. Having multiple queue readers active is one way of getting faster processing of messages. doing conversation reuse, using the same conversation handle over and over again allows you to do a receive into a table variable so that you can process multiple messages concurrently. There's a lot of ways to improve the performance of processing messages. It just depends on your specific business requirement and the rate that messages are being received into your target service or initiator service based on the flow of data that's happening. So if there are no other questions, thank you for watching. And like I said, my email address, jonathan@sqlskills.com. If you have trouble with any of the demonstrations when they get posted, I'll be happy to entertain questions by email and kind of step you through what might be going wrong. But it's pretty straightforward. The implementation of a basic single database architecture is really quite simple, and everything's included in those demonstration scripts.
So Jonathan, hey, this is Mark. So we really appreciate you taking time out of your day to give us the presentation. It was fantastic, a lot of information. What we will do though is obviously we archive the meeting. Like I said at the beginning, it'll be on in just probably a couple days. We like to give it at least, we say a week, but hopefully it'll be out there in a day or two, and then we'll also put up any information, scripts or whatever, whatever else you'd like us to post in reference to this, as well as a link to SQL Skills, your contact information, and I mean, if you give it to us, we'll put a link to Jonathan's blog as well. So I encourage everyone to check it out. Again, though, Jonathan, we really appreciate you taking the time out. I'd like to thank all the users who logged in to check out the blog or check out the seminar today or the session. One last thing, again, we will take everyone's name that was in the virtual meeting today, send it to PASS, and they will pick out someone that will win a free comp code for the PASS meeting later in the year. But if you have any questions for Jonathan or for us, in the meantime, you're welcome to go to our website or email Jonathan directly. Again, thank you very much. We appreciate it.